So we're going to add u plus v, and we're going to do that visually. I'm going to put another paper here to save my table. Okay, so u is 3, 4. 3, 4. All right. And then v is 5, 7. So if I wanted to do this in the triangle method, then I would go 5, 1, 2, 3, 4, 5, and then 7. 1, 2, 3, 4, 5, 6, 7. Three, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, so that works. So there's v. And then uv is a little tricky here because it kind of add together. So 3 and 5 give us 8. And then 4 and 7 give us 11. So we'll check here. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. So there's that. UV. Turns out they have a pretty similar slope there. You almost can't tell on this visualization that they would look different at all. U minus V, well, we would still start with U here, and then head to tail we would go 5 this way and 7 down. So each one of these is going to be the opposite. So the opposite of V is -5, -7. So we're here, we're going to go -5, 1, 2, 3, 4, 5, and then down 7, 1, 2, 3, 4, 5, 6, 7. Okay, so if you, I'm going to put it right to the side just a little bit so you can kind of see what's going on here. That's the opposite of V. So the end result here would be from, grab a different color for you so you can see it. The end result would be from the origin to our end result, that idea of displacement. Like that. So this vector right here, that guy is u minus v. Okay, so that's the triangle method. Now let's say I wanted to do it using the parallelogram method. It's a little bit different. It can be helpful if you, particularly if you already have two visualizations and we want to look at two vectors that are already on the coordinate plane and we want to look at what it would look like if I added or subtracted them. So we're going to put u, 3, 4 on the coordinate plane. And we're going to put v on the coordinate plane, 1, 5, and then you can see they almost look like they have the exact same slope. Just going to make this guy a little bit tricky. But what we're going to do is we're going to kind of draw in the pieces that are missing here. So that guy, and wow, this one's really ugly. And then let's look at a different one. let's look at, let's talk about vector A being 1, 5, and vector B, let's let it be 4, 2. Oop, vector B. So 1, 5. There we go. So there's A. 4, 2. That looks a little better. So now we're going to make our parallelogram here. So we're going to go up 2 over 4. And then we're going to make a parallel for this guy also. And so this diagonal right here, that diagonal, is A plus B. We're going to just scratch this guy right here. Look down at this one. So that's the parallelogram method. So good if you already have A and B already drawn and you just want to find what A plus B is. Okay, there's one other thing here I want to look at, which is kind of a different notation. It's called IJ. So I is representative of our horizontal. Oop, too big. I is representative of our horizontal here. And J is representative of our vertical, which is kind of weird because we've always worked with I and thought about imaginary when we thought about I, but here I think it's an engineering thing. I is our horizontal and J is our vertical. So if I want to talk about a vector in IJ notation, I will say the length of the horizontal is something I and the length of the vertical is something J. So we're going to show exactly what we just did with that vector A plus vector B, only we're going to show it in IJ notation. So if I wanted to talk about vector A plus vector B, first thing I would do is I would write it in IJ notation. So I would say 1I plus 5J equals vector A, and vector B is written as 4I plus 2J. And there's nothing really fancy here we're going to do. If I want to add vector A and vector B together, I'm just going to add the I components together and add the J components together. So 1I plus 4I gives us 5I. Okay. And then 5J plus 2J is going to give us 7J. So this vector A plus B could be written as 5I plus 7J. Okay. Or if you wanted to write it in component, you might write it like that. Or like this. Sometimes you see them like this too. Not a permutation or a combination. It's just a different notation for vectors. Okay. If I wanted to do vector A minus B using this notation, be the same thing. 1 minus 4 would give us negative 3I. 5 minus 2 would give us 3J. It's just another notation. We're going to work with them throughout chapter 9 and 10, this IJ notation. So It's not anything tricky, just a new notation.